Hello everyone, so today we are going to be working on adding polynomials, and we are going to learn two different methods on how to do that. This first one is horizontal addition, which is similar to what we did in the last video. Now what I'm going to do is I'm going to highlight the like terms with the same color, so the 8x squared and the 9x squared are like terms because they both have x squared in it. Everything's already highlighted and colored because my phone decided to randomly stop videoing and didn't save the video that I made, but it's okay. I didn't feel like wasting another piece of paper. So they're already highlighted and done, but you'll get to see me do that for the next problem. So what we're going to do first, let me switch hands here really quick. So we're going to add our 8x squared plus 9x squared, which gives you 17x squared. And then we have our yellow terms. So we have negative 7x, and it's really important to include the sign with the term. So it's not 7x, it's negative 7x. So we have negative 7x plus negative 5x, which gives you negative 12x. And then we have a positive 6 plus a negative 13, which leaves us with a negative 7. Now we can't simplify this any further because none of these are like terms. So this is our final answer, 17x squared minus 12x minus 7. So for our second problem, we have the quantity of 6a cubed plus 12a squared minus 15a plus 4a squared minus 12a plus 8. So for our first term here, we have 6a cubed. So I'm going to highlight that with pink. Now we don't have any other cubed, so that's our only pink number. So we're going to move on to our next term, which is 12a squared. And we have another a squared term over here. So we're going to highlight that too. Now, some of you might be able to just see this and be able to do this very quickly in your head, and that's okay. That's actually pretty good. But I'm going to highlight things and take it slow just in case you don't. Because this stuff took me a while in high school. I always ended up missing a term and having an extra term lying around somewhere. All right. So our next term we have to work with is our a term. So we have negative 15a and negative 12a. And then we have this lonely plus 8 over here. So the 6a cubed doesn't have anything to combine with, so we can just bring that down. And I'm going to cross it off. So then we have our yellow terms, or our a squared terms. So 12a squared plus 4a squared gives us 16a squared. So then we have our blue terms, which is negative 15a plus negative 12a, which leaves us with negative 27a. And then we have nothing to combine with our purple 8 over here, so we're just going to bring that down. And then double check that we have no like terms in this expression, and we don't. So that's our final answer. 6a cubed plus 16a squared minus 27a plus 8. So now we're going to move on to Ooh, turns out I can't talk and write in cursive at the same time. But we are moving on to our other strategy, which is vertical addition. So for this one, we have 3y to the 5th plus y to the 4th plus 2y cubed minus 2y plus 5 plus 2y to the 5th plus 3y cubed plus y to the 7th, I said that backwards, plus 7y, sorry about that, plus 2. Now for the vertical addition method, what you do is you rewrite this one, this first polynomial, now what we're doing is we're kind of reinventing the idea where you write your addition problems like that. So your 7 is lined up with the 5 because it's in the ones place and they're like terms. So what we're going to do is we're going to take this polynomial and then we're going to rewrite this polynomial to match up its terms with its like terms down here. So this 2y to the 5th, that can fit under here. And the 3y to the 3rd fits here. Our 7y fits here under this negative 2y, and this 2 fits here. Now this y to the 4, you can kind of imagine that there's a 0y4 here, because anything times 0 is 0, so it's like this isn't even here. But it can be a placeholder if that makes you feel better, or makes it easier to see for you. Sorry, my line was a little crooked there. But so then we just add down. So 3y to the 5th plus 2y to the 5th is 5y to the 5th. 1y to the 4th plus 0y to the 4th. You just kind of bring it down. Get y to the 4th. 2y to the 3rd plus 3y to the 3rd is 5y to the 3rd. And then negative 2y plus 7y gives you plus 5y. And then 5 plus 2 is 7. Double check that you don't have any extra like terms, and we don't. So this is your final answer. All right, and let's try one more. So we have x cubed plus 5x plus 3x squared plus 2 plus 4x cubed plus 3x squared plus 14. Now when I rewrote this one, I switched the 3x squared and the 5x. We can do that because of the commutative property. And that's just because it's good math grammar to write your expressions in with your exponents going in a decreasing order. Why? I'm really not sure, but math grammar. So we have x cubed plus 3x squared plus 5x plus 2. And then we're going to bring our 4x cubed to match up over here. And our 3x squared over here. Now we don't have an x term in this polynomial, so we can just add a placeholder. And then we have our 14. We can add these up. So x cubed plus 4x cubed is 5x cubed. 3x squared plus 3x squared is 6x squared. 5x plus 0x is 5x. And 2 plus 14 is 16. Check that we don't have any extra like terms, and we don't. So this is your final answer. And that's it for adding polynomials today.